right, Happy New Year. All right, at various equations, which is a different unit, we're doing a couple other equations, one of them being the absolute value. Now, everyone understands what absolute value is. You just say, oh, it's the positive. I understand, but that's not exactly what it means. Absolute value means the distance an object is from 0. So how far away are you from 0? That's what absolute value means. So this says right here, the absolute value of x is equal to 4. So it's saying what values, remember x is just like what values have a distance from 0 that's 4. So if we do that, where's 4? Well, 4 was right here. Okay, but this is 0, and that's 4 units away. Okay, but also, -4 is 4 units away. So the objects that are 4 units away from 0 are 4 and -4. So that's the idea of absolute value. It's distance from 0. So two objects are always the same distance away from 0. And that's the basic idea. Okay, so if we look at this one, and now again, this number line is here is just for demonstration purposes. We won't be actually graphing these on a number line. So this is the absolute value of x plus 1 is equal to 7. So what value plus 1 would always, that distance always be 7? Well, the way that we do these equations, x plus 1 could be at 7, and x plus 1 could be at -7. Oops. These are the two places, these are the two places that this could be true. So if I solve this, x is 6, and x is -8. So if I put -8 in here, that distance is going to be 7. If I put 6 in here, x is going to be 7. Or, the distance is going to be 7. So that's the idea. Anytime you see these absolute value lines, it basically means I'm going to be creating two equations. Because there's always two possibilities. It's going to be on the positive side of 0 or on the negative side of 0. So this one, the answers were -8 and 6. All right, so that's just basically how this works. Anytime you see absolute value, you go, okay, I'm creating two equations. Those two equations, the absolute value, that distance is going to be 15, but that distance could also be -15. And we solve. That's it. So you're basically solving two equations in one. Two different equations, but remember the moment that the absolute value function is isolated, meaning it's by itself on this side of the equal sign, that's the moment you set up your two equations. So for example here, see that 3? That 3 is not inside the absolute value. Right here. It's not inside the absolute value. It's outside. So I have to get rid of it. So the absolute value has to be by itself before I can create those two equations. So 2x minus 4, the absolute value, is equal to -2. Now, this is an example where there is no solution. And how do I know that right away? Well, I am psychic. No, because I made up the problem. No, because the absolute value of 2x plus 4, this means distance. Is distance ever -2? No, never. So there is no solution here. If an absolute value is ever equal to something negative, it can't be done. We don't have eyes or anything to deal with that. Okay? Okay, so we're looking at this, And we're saying, okay, we have this absolute value. This has to be by itself. That means that this 2x has to go over here, and this negative has to be removed. So we have to do those. And you have to think of it, you can almost think of it as substitution. Think of this thing as being just a big x. And this is 2x minus, okay. Maybe x wasn't the best example. However, solve it. So I'm going to subtract my 2x. And I get negative the absolute value of x plus 3 equals 9 minus 2x. And then this is negative 1 times x plus 3. So if I divide everything by negative 1, this is now by itself. X plus 3. The 9 changes to a negative 9. The negative 2 changes to a positive 2. And I just like writing it like that better. So now at this moment, absolute value creates your two equations. Remember, this is the distance. This does not change. Stays the same. Okay? This is the one that changes. Okay, so please just remember that and try to grasp that, and please don't tell me that I never told you that. Okay, so it's x plus 3 is equal to 2x minus 9, so that one's exactly the same. But then x plus 3, that stays the same. However, everything over here changes, so the 2x becomes a negative 2x, and the negative 9 becomes a positive 9. And that's only for the second equation that everything changes. Now we solve these. These are just linear equations. We just straightforward solve them. Add 9. And x is 12. Sorry, I'm sick. So this is 3x plus 3 equals 9. Subtract 3. And x is 2. So we have two solutions, 2 and 12. Going back and checking is a good idea, okay, because that whole negative situation is a problem. So we should go back and check back into the original. So I got 12 and 2. I'm going to check here on a pause, okay? Okay, so when I checked this, I found out that when I plugged in 12, I got 9 equals 9, and that was awesome. So this one checks out. 12 is good. But when I put a 2 in, 2 times 2 is 4, minus 2 plus 3 is 5. Now this minus is outside the absolute value, so I don't change it to positive like you would if it was inside. So it's 4 minus 5, which is negative 1, which is not equal to 9. So that's a reject. So the only answer we have here is 12. Okay, moving on to the next one. Right here, 2x plus 2 plus whatever, you can read it. Okay, we have to isolate this absolute value first, meaning get everything away from it. So this is an r, me saying that this is an x. You can use substitution here to see that I can't add that 2 and the 5. Okay, you have to solve. You have to do, subtract your 2, divide by 5. You got to do that. You cannot add the 2 and the 5. So just be careful there. I like to put those on a lot of things. Okay, to see if you know your order of operations. So this is 70, divide by 5. Equals 70 divided by 5, 14. Okay, try and solve this, and we'll come back. All right, so you created the two equations, hopefully. This one is exactly the same. 6 plus 4r is 14. This one, the only thing that changes, remember, is that 14. And you solve, you should have gotten two answers, 2 and negative 5. Okay, when we check them, they both work. Okay, you plug in a 2 here, and this becomes 70. It's actually 14 in here. So 5 times 14 is 70. 70 plus 2 is 72. This one over here, you plug in a negative 5, you get negative 14, but that is in the absolute value. So when you actually evaluate an absolute value, it's positive. So it's positive 14 times 5, which is 70, plus 2 is 72. So they do both check out, and we'll see you on Tuesday.